Here we go, folks. We're looking at normal distributions, example number 5. We're told that the lifetime of a refrigerator is normally distributed. All right, so that's what allows us to draw a bell curve here. So we'll draw a bell curve here to represent normally distributed. And the mean is 13.4 years. Standard deviation is 2.8 years. So again, keep in mind the variable here is the number of years that a refrigerator lasts. That's our variable x. All right. This is backwards from the questions we've looked at earlier. So here's the thing, in this one, they tell us that the manufacturer wants to provide a warranty so that only 3.5% of the refrigerators will be replaced before the warranty expires, and they want to know what should be the length of the warranty. So the length of the warranty would be how many years? An X, a number across the bottom here, all right? How many years should they set the warranty? I wish I had a math formula on these types of questions to tell you where to put the X. You have to think about it logically. So, let's just flip a coin. Let's suppose we didn't know what side to put that on. Let's suppose we put the X up here. They set the warranty up here somewhere above 13.4 years. Make up a number, 15 years. All right, now think about how a warranty lasts. And if I give you a question like this, just use the same logic. So just follow along if you will. Well, see, if we set the warranty up here like say 15 years, wouldn't that mean that every refrigerator that died, that broke down before it reached that age would be under warranty? And so if we were to put it up here above the mean, like at say 15 years, wouldn't all these refrigerators here be under warranty and we'd have to replace them all? And that's more than half, right? Here's 50% plus some more. That's more than half the refrigerators would fall under warranty. We only want to have to replace 3.5% of them. So I would hope you would agree with me that logically it doesn't make sense to put that warranty above the mean. It needs to be somewhere down here, below the mean. Say 8 years, something like that. But these would be the refrigerators that would fall under warranty, the ones that would break down before they reach that age. And that, conceivably, could be 3.5%. So, that's where the 3.5% would come into the play. That would be that lower tail, in other words. Now, remember, for the purposes of our table and everything, we want to always change those to decimals. So 3.5% would translate to 0.035. Yes, if we set the warranty here, only 3.5% of the refrigerators, theoretically, will break down before they reach that warranty, and we'll only have to replace 3.5% of them, therefore. All right, so what I would then suggest is drawing the corresponding standard normal, because we've got to get this to where the table can help us out. So we're looking for the z-score that would create basically a lower tail of 3.5%, just like the picture above. So, we start thinking about the table and everything, and we say, hey, good old table, look at that. Hey, table, I got a picture of a lower tail here. And that table will look at you and say, as it always does, table want middle sliver. Table not do lower tail. Table do middle sliver. Please give table middle sliver. And we need to go, oh yeah, that's right. So, I want to remind you that we talked about this on assignment 16. If we want to find that middle sliver there, that middle region there to make the table happy, the table wants this, right? It always does, this table. Then we need to realize that we need to take the entire lower half of the bell curve, which is 0.5, and subtract that lower tail from it, and that would give us that middle sliver that the table wants, wouldn't it? And then the table will be happy, right? Okay, so let's take that lower half of the bell curve, 0.5, subtract that lower tail of 3.5%, and I believe that will give us 46.5%. Yes, and that's the middle sliver that the table wants, 46.50. Yay, all right? So this would be sort of like some of those questions we did. I believe it would have been on example 2, where we had particular regions described, particular areas, percentages, and we wanted to find the z-score. All right, so now, if you recall, we would go back to the table. We're ready for the table now. We've got a middle sliver, table happy, and we're looking for 46.50 basically. And as often often occurs. 4650 is not exactly in the table. I see it surrounded by 4649 and 4656. And in a case like this, you always go with for our purposes, we'll go with the one that's closer. So this is only a difference of 1, whereas this is a difference of 6. So it's this one, 4649 and 4649. Sorry, I'm so close to this. 1.81. 1.81. Oh, and it's below the mean, so it would be negative 1.81. All right, now that's imperative that we remember that negative. We want that warranty to be 1.81 standard deviations below the mean, is the interpretation of that. Now, is that the number of years they should set the warranty? No, that's the number of standard deviations. It needs to be from the mean. So we're not quite done, but we're very close. So now at this point, what we can do is we can say, how do we change z-scores into the actual value of x? How many years should they set the warranty? I consider this to be our interpreter. This is what allows us to speak back and forth between z-scores and values of x. There's multiple ways to do this, but what I'm going to recommend is that we write down that little interpreter there, and we plug in the numbers that we now have available to us. We know we want that warranty to have a z-score of negative 1.81, right? We want it to be 1.81 standard deviations below the mean. X is what we wish to discover, all right? So that remains a variable. Mu, that'd be the 13.4 years, and sigma would be the 2.8 years. And now guess what? This is just algebra. Solve for x, all right? So, go back to your algebra training. This is linear because x to the first power. So I think the first appropriate thing to do would be to clear the fraction by multiplying both sides by 2.8. So this is where I'm going to need to grab a handy dandy calculator here. And on the left-hand side, 2.8 times negative 1.81 becomes negative 5.068 equals, over here it cancels, leaving x minus 13.4. And then of course we add the 13.4 back over. I'm excited, we're almost done. All right. By the way, this number means that that warranty should be a little more than just a little bit over 5 years below the mean. And then when we add that 13.4 over, and I sure hope I'm poking these numbers in the calculator correctly, but it turns out that x would be 8.332, and remember that's years. So, if they set the warranty at 8.332 years, they'll only have to replace about 3.5% of the refrigerators, theoretically. So, yes, that's backwards. I wish I had a math formula for you of how to set those up. But anyway, we'll practice some more of those. So again, that was example 5. Let's move onward. I miss you guys. Hang in there, everybody. We're going to do this.